So today we're going to add another layer to what we've been learning. This is lesson 36. It starts on page 21 in your packet. Okay, so we're going to talk about angles of elevation and depression. And these are going to be notes and practice, all right? And so before I'm going to do a video within a video. So I'm going to show you a quick video, and then we'll come back and take some notes. Let's see here. All
right. SOHCAHTOA, Pythagoras, sine rule and cosine rule, and all things trigonometry actually have a lot of uses in real life, such as working out distances to things, and heights of buildings, and mountains, and navigation at sea. An important part of useful trigonometry are angles of elevation and depression. If you're standing and looking up at an object, the angle from your horizontal line of sight up to the object is the angle of elevation. Whereas, if you're looking down at an object, the angle between your horizontal sight line and the object is known as the angle of depression. Be careful to remember that this is the angle of depression and not this. It's a common mistake to make. We then use all of our trigonometry skills to solve problems involving angles of elevation and angles of depression. Let's look at some examples. Next time you're out and about, stand 10 meters away from a building. Guesstimate the angle of elevation from your sight line to the top of the building. You can now use SOHCAHTOA to work out the actual height of the building. And remember to add on your height to get the correct answer. Here are some questions for you to do. Pause the video, work them out, and click play when you're ready.
All right, so the first one says, I'm standing on top of a 300-meter tall Eiffel Tower, looking down at a church with a 30-degree angle of depression. What is the horizontal distance between the church and the Eiffel Tower? Okay, so this is an angle of depression. So when you're working this out, remember you're going to have your horizontal distance here. So this is 30 degrees, which means this is 60 degrees. Now we're looking down at the church, and we know that we want to know the horizontal distance, and we know that this is 300 meters tall. Okay, so this is adjacent, and this is opposite. So we're going to do tan 60 equals x over 300. Okay, and then you can type that in your calculator. It's a simple multiplication problem. Make sure your mode is in degrees. You're going to hit tan 60 times 300, and you should get 519.6 meters. All right, in the second problem, it says the control tower of an airport. And we're looking at a plane that's flying 800 meters higher than them. So we're looking at the plane. This is 800 meters. It's a 35-degree angle of elevation. Please remember it's the horizontal distance to the distance that you're looking. So this would be 35 degrees. We don't have to do that extra math here. What is the horizontal distance from the plane to the control tower? Okay, so now we're going to label our sides. Here's our 90-degree angle. So if we're looking from here, this is opposite, and this is adjacent. So O and A, it's tangent again. And you'll notice you use tangent a lot when you're doing angle of elevation and angle of depression. So this is tangent 35 equals opposite, which is 800, over adjacent, which is x. So you should notice that this is going to be a division problem when you cross multiply. So this would be 800 divided by tangent 35. And when you work it out, you do clear 800 divided by tangent 35. You end up with 1,142.5. And this is meters. Okay, so let's go ahead and see if we worked these problems out correctly. And if we did not work them out correctly, what mistake did we make?
Did you get 520 meters? Did you spot that the angle of depression is here, and so the angle in the triangle is actually 60 degrees? And 1143 meters for the plane. So there we have some real-world uses of trigonometry involving angles of elevation and angles of depression. If you liked the video, give it a thumbs up.
All right, I'll give it a thumbs up later, y'all. All right, let's go back to where we are. All right, so let's take some notes and let's remind ourselves that we have an angle of elevation. So elevate means to lift somebody up. So inside, this is always going to be degrees. We call this the angle. And in this case, it's the angle of elevation. Okay, now this line here, when you're looking, remember that's going to be your horizontal. And then this side here is what we call the line of sight. That's where you're actually looking, if there was, imagine like a laser coming out of your eyeball, that's what the laser would look like. All right, now if we're talking about an angle of depression, it's when you're looking down. So let's say this is y, it's always going to be in degrees. We will call this our angle of depression. Okay, and once again, this time, this is our horizontal. And our line of sight, again, if we were to take a laser from our eyeballs, that's what a line of sight is. And again, a lot of times we'll be using tangent when you're solving these. It's just the way it tends to work out. Okay, so if we're going to take some more notes on this, it says you'll usually be given two of the following three pieces of necessary information to set up a problem, and then you use a trig ratio to find the third. So let's go ahead and look. How far away from the object the viewer is, what the altitude is from the object to the ground. So that would be like an airplane. And what the angle is between the horizontal and line of sight. All right, so it's either going to be an angle of elevation or depression. Okay, so if you want procedural steps, the first thing you always want to do is draw a picture, label your sides, pick the ratio. So this is where you do so, pa, toa. And then you're going to set up and solve your trig ratio. All right. I know what's going on. There we go. Here are some examples. So it's going to tell us to round to the nearest hundredth of a foot. So the first thing we're going to do, our picture's drawn, so we're going to read our problem. A hiker is standing 220 feet from the base of a hill. This is the base of the hill, so I can label this 220 feet. The angle of elevation from where he's standing to the top of the hill is 29 degrees. You want to know how tall is the hill, so that's x. So when I label my sides, I'm going to label this O, and this is A, So again, this is going to be tangent 29 equals x over 220. And this is a multiplication problem. And I can see that when I cross multiply, 1 times x is 1x. So you're literally going to type in your calculator, tan 29. Make sure you close the parentheses, then hit times 220. If you don't close the parentheses, you'll get the wrong answer. And so x equals, round to the nearest hundredth of a foot. X equals 121.95 feet. Number 2. A 30-foot ladder forms an angle of 50 degrees with the ground when placed against a brick wall. So you're going to quickly draw a brick wall and a ladder here coming off the brick wall. All right, and then it says the angle with the ground is 50 degrees. So right here, this is the ground. So this angle here is 50. How far up the wall will the ladder reach? This is x, and it says a 30-foot ladder. So I know this is where 30 feet comes in. So that's my hypotenuse, because I know this is my right angle. The building and the ground are going to make a right angle. All right, so now let me label my sides. I'm looking from here, so this is opposite. This is hypotenuse. So this is going to be sin 50 equals x over 30. I'm going to put my 1 under here. So this is a cross multiplication problem. So I can see that x times 1 is 1x. So this is going to be multiplication. So I'm going to literally type in sin 50, close my parentheses, times 30, hit enter, and I should get x equals 22.98 feet. Hopefully this is getting a little bit clearer. Number 3, Alex is standing on the ground. So I'm going to draw Alex. He's standing on the ground, and he looks up to see a plane flying in the sky. All right, so let me make Alex a little bit smaller. He's looking up and he sees this plane. It's flying at an altitude of 2 miles. So this distance here is 2 miles from the ground. And the distance along the ground is 5 miles here. So we want to know this angle. If I just extend this down here, we want to know this angle right here. So let's say Alex is laying on the ground. If it's flying at an altitude of 2 miles and the distance along the ground is 5, what is the angle of elevation? Okay, so that's what we want to know. So we're going to label our sides. We're looking from here. This would be opposite. This would be adjacent. So this is going to be tangent. Remember, we don't know the angle, so it's tangent -1 equals 2 over 5. So you have to hit second tan, 2 divided by 5, close your parentheses, and hit enter, and you should get 21.8 degrees. All right, let's see if we can get another example in a minute. All right, this is one, Michael's, whose eyes are 5 feet from the ground. So here's 5 feet. This part right here, his height, is 5 feet. He's standing 30 feet away from the base of the building. So this part right here is 30 feet. He's looking up at a 50-degree. And we want to know how tall is the building. So we're going to figure out this part is x, and we've got to add on 5 feet to it, because that's his height. It looks like 15, but it's 5. All right, so this is opposite over adjacent. So pause and set up the problem. Don't forget that you have to add on his height, which is 5 feet. Okay, your assignment is to finish page 23, 24, and 25. And you will be presenting one of the